Hey everyone, welcome back to our video series on Amazon Data Analytics Specialty. I hope you are doing well and staying safe out there. Today we are diving into the world of cloud data warehousing with the Amazon service called Amazon Redshift. So let's find out what exactly is Amazon Redshift. Amazon Redshift is a cloud-based data warehousing. It is designed to handle and analyze large volumes of data in highly scalable and cost-effective manners. Similar to the other data warehouses or traditional data warehouses, Redshift is designed for online analytical processing rather than the online transactional processing that's known as OLTP. Redshift is available in two options. One is serverless and the second is the provisioned cluster. Serverless, where the data warehouse is built and run without the overhead to provision or manage the cluster. While on the provision cluster, we have to provision and manage the cluster with like no IT overhead, but still we need to provision the cluster. And if we think about the alternatives of Amazon Redshift then the options are BigQuery, Snowflake, Azure Synapse Analytics. Redshift offers several advantages, including like easy SQL integrations. As you can see on the screen, these are the various advantages of Redshift. The first one is like easy SQL integration. Second is the scalability. It is designed to scale seamlessly from handling gigabytes of data to petabytes of data. And one of the biggest advantages, like it integrates seamlessly with Amazon, like various Amazon services, such as like S3, DynamoDB, Amazon Aurora. Additionally, recently Redshift have like we can integrate with Apache Spark via EMR, and that enables real-time analytics and machine learning capabilities within the Redshift without a need for a complex ETL process in Redshift. Other benefits is like it have built-in replications and backups. So these are like various advantages of Amazon Redshift. And what is Redshift? As we said, like it's a cloud-based data warehousing, pretty much like a traditional warehouses from like a working structure point of view, but like it have all the cloud benefits like as we mentioned. So now next we will look into the Amazon Redshift architecture. So on the screen we have a simplified diagram representing the architecture of Amazon Redshift. Redshift is basically, it's a cluster of a collection of compute nodes and the leader nodes. So if you look at this, as I mentioned, like Redshift is available in serverless or provision. So in the serverless, we have literally no control. Like this architecture is pretty same. It's just for serverless data warehouse, like we don't have to do anything. We don't have to manage or provision anything in the cluster. While if we are using a provisioned cluster, like this is like that's the architecture for it. So it's basically, it's a cluster. You can look at, sorry, like it's a cluster which is a collection of compute nodes or leader nodes. So if you look at into this cluster is a collection of a compute node and leader node. So leader node basically facilitates the communication between the client application. So for example, this JDBC, like if you're using a SQL client and using a JDBC driver to connect with Amazon Redshift, so that communicates with the leader node. And other than like facilitating the communication between the client application, it also communicate with the compute nodes. It manage the like client connections, receive queries, create and optimize query plan, and after that, like it distribute that query execution plans to compute nodes, aggregates the results before sending them back to the client. So these are the various things the leader node do. On the other hand, compute nodes are the actual workhorses for the Redshift cluster. They handle query processing, data storage, and parallel execution. Each compute node consists of CPU, memory, and local storage. And if we think about like here, we can see there are like few blue dots. So basically these are called compute slices. it is like basically a compute node is partitioned into slices, and each slice is allocated a portion of the node's memory and disk space, where it processes a portion of the workload assigned to the node. And why they do that? So they can like process things in parallel. Okay, so this is basically the architecture, and it is pretty much like any cluster where we have one main node, like a leader node, which manages the communications between, divide the work, create and optimize query plan for them, distribute it, and after that compute nodes are the actual workhouse which execute those things. Okay, next we will look into the like various factors which improves or which make Redshift achieve high performance while running queries. So there are various factors. The first one is the massive parallel processing. So Redshift distribute data across multiple compute nodes, allowing complex queries to process in parallel. Each node runs query segment on the portion of data, leading it to the faster results. So as we saw in our last, as we saw in the architecture or the last slide, like the Redshift distribute the data and the task to all these slides, and they run in parallel, and that's why they are able to execute these things faster. Sorry. The next thing is the columnar storage. This format reduce the disk input output, improve query performance, sorting columns, optimize filtering, speed up the data retrieval. So if like as you can see in the picture, like in column storage, if you're selecting, for example, like in your select, if you have product and customer, then it will just go to these two two slices. If it is a row store, then it have to go to each. So that's the advantage of column storage. Like the shuffling of data is less, and which improves the performance. Like that's the nutshell. And the other factors are pretty much like the as we saw in other places too, the compression, caching, query optimizers, and compile codes that make the Redshift queries achieving like a high performance. Okay. Redshift provides like multiple methods for data loading. So once like our cluster is over, the next step or for any data warehouse is how we load the data. So for that, it provides like various methods for loading the data. Each is suitable for a different scenario. I'll say the most common one is the copy command. So copy command is the primary method for bulk loading. It's efficiently load data from sources like, for example, S3, AMR, DynamoDB, or even like a remote host where you do SSH and load data from there. It is ideal for large data volumes and offer high performance. So that's like the copy command. The second option, and on the image you can see it's very straightforward. Like I have just two snippets. These are snippet of code. So it's basically you write copy where you want to copy this from, like for example, if you're copying from S3, this is the we provide the S3 path, credentials, and what kind of format, and if you want to ignore header and all, like so for example, if it's a CSV and in your header you have a column, so you want to ignore it. So these kind like various parameters you find, and below there is another example of the same thing where I'm copying the data from S3 bucket. Here you can see my table name is test. I'll explain you what is dev public. Basically dev is, you can consider as your or it's your database, public is your schema, sorry, public is your schema, test is the table name, and we are copying data from here. And after that here, instead of then we have provided the role based on which we are able to copy. Then what was the format of the file? It was a delimiter file where delimiter was a pipe, and the reason. The other two ways are insert and Redshift data API. Insert command is basically like it's useful for like a smaller data sets where we want to load data row by row. So like think about it from a traditional data warehouses where we can insert queries from one table to another. So that's like another way to do it. The last is the Redshift Data API, which provides an interface for programmatically loading data into Redshift. And it's provide like more flexibility and integration capabilities for like custom data loading workflows and applications. Okay. So some other important topics related to data, Amazon Redshift. So as we know, like the architecture underneath the Amazon Redshift is it's bit different from the traditional relational databases. So here, when we are designing the table, there are a few things we need to keep in mind for the like a better performance within the cluster. Okay, so there are two important topics which we need to be aware about. One is the distribution key, and the second is the sort key. So I'll start with the distribution key. So basically, distribution key is like how data is distributed across compute nodes, and it is defined at the table level and can consist one or more columns. Let me go to my GitHub. I have a really good page on this. Okay. So basically, as I mentioned, distribution key is basically, as the name says, is like how data is distributed across compute nodes. And as I mentioned, it is defined at the table level and can consist one or more columns, right? So there are three types of distribution keys. One is even, second is key, and third one is all. So even is basically, in this style, data is distributed evenly across compute node without any specific column-based distributions. And like it is suitable for those situations where we don't know if we like query performance is not critical, or also when table is not used in those queries where we're doing join, or also if we don't have a very clear choice for like a distribution method. So there are like two other, key and all, which I'll explain, but this is like basically it use a round robin approach and distribute equal number of rows to each compute nodes. And as I mentioned, like when we can't decide basically which key, like if we can't decide a distribution key, that's the way to go. That's like it's your general rule of thumb. If we don't have a clear choice of distribution method, then we go for even. The second is the key. Key is basically chosen based on one or more column with high cardinality or frequently used in the join conditions. So row with the same values and distribution keys are located on the same computing, and which enhance the query performance for join operations. So if we go back to our slide here, you can see, for example, key, we have 4 keys, key 1, key 2, key and key 4, and each key value is stored in one slice. So in that way, if we're doing a join on, let's say, key 2, only this will be touched, and query performance will be faster. And the third one is all, which is basically it copy the full table on each compute node, ensuring that data is available locally. And it is useful, or I'll say the best use case for it is that's when we have a small dimension tables, or you can think about reference tables or lookup tables. For those kind of tables, all is the best option. So we have 3 distribution keys, and based on the distribution key, data is distributed among the compute nodes. So always keep in mind, all is for small tables. We want to copy, like it's just, for example, it's a reference table. Key is like when we have a high cardinality key, and we use a lot in our joins. In that situation, we use key. And if we don't have a clear choice, like we can't decide whether it's key or it's all, or we don't have it's not clear to us, then go for even. I personally prefer even in most of the cases, because then you don't have to worry about it. And here is one more thing, like you will see a term called auto. So auto, if you set auto, then that's my way to go, is like we give our response, the responsibility of selecting the distribution key is to the Amazon Redshift. If you select if you put your distribution key auto, then Amazon Redshift will pick the key, and based on these criteria, if it like it like if it's a small table, the Redshift will use all key. If it founds a like high cardinality table, like high cardinality field, it will use key, and even when there is no clear choice. And how we set a distribution key in a code, you can see, for example, if you have a sales table and you wanna make let's say customer ID as your distribution key, then you just have to type dist key. So dist key is like for a key, basically you have to put dist key. And if you want all, then instead of dist key, we have to use dist style all. So this is the example for that, is like creating like a business domain lookup table, and because we know like it's going to be a very small table, we want this to be distributed on all. So then we use dist style. So these are the major keywords which you need to keep in mind, is dist style all and dist key. Okay, so next topic is, let's go to sorting. Sorting is the another thing we need to keep in mind. So distribution key was the first one, and second is sorting. Sorting is basically, it determines the physical order in which data is stored within each compute node. It's pretty much like index. It's not exactly index, but think it about from like it's indexing. So it improve your query performance like when like data is indexed. So here, like if data is sorted, then it improves your query performance. And there are two types of sorting. One is compounds, two types of sort keys, compound and interleaved. And for compound is basically it's made up of like all the columns listed in the short key definition. So if I go back again in my GitHub, so for example, if we look at this, like the highlighted section here, state and city both are the sort keys. Okay, so this is a compound sort key. So what this is saying, a compound sort key is made up of all the columns listed in the sort key definition in the order they are listed. A compound sort key is most useful when query filters applies conditions such as like a filters and join, and that use sort keys there. The performance of benefit of using compound key decrease when query depends on the secondary sort column without referencing the primary column. And by default, compound is the sort key. So basically, like compound is like all the columns which are listed within it are will be like in the sort key will be the compound key, and they need to be in an order. If we try to like it can backfire too, like it can decrease the query performance if instead of using the primary column we using secondary columns in our query, then it will decrease it. So we need to keep that thing in your mind. Interleaved sort key is gives like equal weightage to each column or subsets of column in the sort key. If multiple queries use different colors for filter, then you can improve the performance for those queries by using interleaved sort style. When query use restrictive or predicts on the secondary sort column, interleaved sorting significantly improve query performance as compared to compound sorting. So that's all for like a distribution key and sorting key. But here is a general rule of thumb, and this is like that's how I follow, but it's not necessarily like you have to do it. But I found like this works pretty much in 80% of in 80% of situations it's worked pretty well. So distinct should be the column used most in the joins between two tables. So I personally use dist key whenever like I used a column as a dist key whenever it is used a lot in joins. And now, as I said, like even is the other thing which I used a lot, like where I can't find it, I'll basically evenly distribute it. Second is short key should be the column mostly used in your where statements, and use dist style for small lookup, reference, and those kind of tables. So that's like my general rule of thumb. That's not like goes well in all situations, but I found like in 80% of cases this works fine. So keep this thing in your mind. Okay, now let's jump to the demo of Redshift. Let me go to my portal. Okay, so first you need to sign into your Amazon Management Console. You can see I already signed in. Once sign in, search for Redshift, like just type in your search Redshift, and like as I recently visited it, so you can see here. So click on Amazon, click on this, a new page will open. Okay, one second. Okay, so my screen, like when I click on the Amazon Redshift, like it was looking slightly different for somebody who haven't like a who will be doing it for the first time. The reason is because I already created these like my cluster and serverless, so that's why my screen was looking different. So keep in mind, like when you click, like when you search for it, your screen should look something like this. And however, if I do this, like my screen was a bit different. Like for example, it was something like this. Just so don't be afraid if you like see why his screen is different. It's basically just because I have already created the cluster and the serverless. That's why it's different. Your screen should look what's on my screen at this point. And now we like, as we know that or we saw in the beginning of this tutorial, that there are two options available for Redshift. One is the serverless and the second one is the provision one. So for serverless, for like in my case it says go to Redshift serverless, but for you it will be something like create Redshift serverless. So if you click on that, it will take you to the Redshift step. Like I'll show you how to do that too, but in your case, instead of go to, it will be create. And if you want to create a cluster, like you want to provision one, then you click on the cluster one. Okay, so I'm going to show both of you. Before I like I'll show you how to create a cluster. There are two important concepts we need to be familiar with. One is like namespace and the workgroup. Namespace basically reference of the collection of database schemas, users, and tables, and it can be think as a data mart. Like when from traditional data warehouse perspective, it's basically a data mart. And workgroup is basically a collection of compute resources. And why I'm talking about these two, because when you create a cluster, once you have it, or like or you have a serverless for example, a serverless Redshift enable, in those cases, like after that, these are like you create a namespace. Namespace is basically going to be like, I'm going to show you in a demo like what exactly I mean by that. Okay, I'll start with the cluster one. So you click on this create cluster. After that, you give the cluster name, and this is like here it is called cluster name, but actually it is the namespace name, and it is something as I mentioned, consider as a data mart in your organization. I'll show that in your query editor. So for like if you're doing it with the cluster, give it a name. So we keep it like same Redshift cluster 2, and after that, like they give you the choice like whether you wanna pick the cluster or you want Amazon to help you. So I'll say I'll pick it. So depending on like on your workload, you can pick depending on your budget, workload requirements, you can pick I'll say you can pick your the server size. Like it could be anything. I'm just picking by default one, and then number of nodes, and as I say, like it depends on your requirements. This is something like it's in your control. And the good thing is like it give you the estimation, like what will be your cost, what will be like your storage cost, and all those kind of things. And if you want to load some sample data, you can do that too. And after that, like a username, user password, cluster permissions. If you want to associate a role, you can associate that too. In this, like I'm not doing anything, I'm just showing you. And after that, you just need to click on create cluster. I know like I picked a very big cluster. Let me reduce the size. I just don't want to pay too much. Let me go to the cheap one. This one seems cheap. Yeah, so you see 360 number of nodes. Make it so you see it decreased $180 per month. Not bad for a demo kind of thing. This will be my storage. I'll click on this load sample data. So it says ticket will be the sample data will be loaded. Here my username is AWS user, so I'll create a password here. I'll do a simple password here. Okay, after that I'll keep everything as default because I'm going to show you how to create a role, and like I'll keep everything else like a default, like network security maintenance, and click on create cluster, and after that it will start working. So you can see I already have a cluster named Redshift cluster 1, and now it's creating second cluster with name Redshift cluster 2. And creating a cluster will take a few minutes. So in meantime, we'll go to our serverless. So on serverless, I'll go on serverless side. I'll close all these, whatever is working here. So so I was talking about namespace and work groups. So these are the things you need to keep in mind. And the one more thing I want to, like, before I jump there, like serverless currently at the time of this video is recording is available with free credits. So we get $300 free credit when if we starting Amazon Redshift serverless here. So I already have 2 namespaces, and you will be, as I say, like if you're doing it for the first time, it will be easy for you. You instead of like go to Redshift serverless, you will find, oh, create Redshift server. You click on this, it will go from there. But think about this: you already created one. Then how you create a new data where like a new namespace in it. And I say namespace is basically collection of database tables, users, schemas, and all those things. And work group is basically a collection of compute resources. Okay, so you click on this create work group, give a work group name. So I'll say data tech demo 2. Here is the base capacity. Like this is the minimum, like your capacity for your serverless. If you want, you can increase or decrease. So in this case, we'll decrease because it's a demo. Rest of the stuff you can, as I say, you can keep it exactly same. Then click on next, and here it says choose namespace. So this namespace is, as I said, like it's going to be your data warehouse name. So here we will name it, for example, data tech demo 2. I'll keep everything as it is, like I'm not attaching any role or anything, and click on next, review, and then I click on create. It will create, and it will also take few minutes to spin up and get like to set up. So in the meantime, I'll show you something. Like if I go to my, for example, if I go to my serverless dashboard, so here you see, let me close this. We have 3 namespaces currently. So data tech demo 1, I just created in front of you. The other 2 were already there, Marvel 1 and default. And if we go here and click on query editor, this will open a query editor pretty much like our SQL clients as we have in traditional data warehouse, but with much more things in it. So if you look at this, don't worry about what's on the right side, just look at all on the website things. So if we go here, we have 3 namespaces, Marvel 11, default, data tech demo 2. You will find same serverless, data tech demo 2, serverless default, serverless marvels, and namespace. You coming from DB2 backgrounds or to relational data warehouse background, just think about as a like data mar, or in DB2 actually namespaces, this is the namespace. And if we expand, for example, if we expand marvels, so in this one, like you will find these are the various databases. So marvels is a namespace, and these are various databases. If I expand this, like dev is the name of the database, public is the schema name, and within the schema we can have tables, views, functions, stored process, pretty much like a traditional warehouse, like irrespective of whatever you're talking about, SQL Server, prod SQL, and Postgres, anything. So just think about this like it's a namespace, database name, schema, table. So you can see this is namespace, this is the database name is div, public, and table name. Okay, so it's pretty straightforward. So whenever like we have to create a new data mart or data warehouse, just go to Redshift, create a new namespace, and you will have a new one here. So for example, this is grayed out because still like it's still not available, it's still creating. It take few minutes, as I mentioned. Okay, now I'll show you. If we go to provision cluster dashboard, there we have two cluster names. Like if you look at this, so in serverless it's called nameless, here it is called cluster name. So if you look at that, Redshift cluster 2 it's still creating, Redshift cluster 1 it is already available, and if we look in our query editor, these two both are available. And if we expand, it's pretty same. If we expand this, then it will have database in it. If we expand this, it will have schema underneath it. If we expand this, it will have tables underneath. If we expand this, like you will find various tables underneath it. I hope like it makes sense to you. Like what's the difference between like a serverless and provision is just the like here we call data warehouse as a cluster, and there we call namespace. And in cluster we define we pick our choice, like what kind of node size we want and all those kind of things. Okay, so once this is done, I just want to show you, once we have a table, now the next step is like how we load the table. So I told you there are like three ways to do it: copy data, insert, and the third one is Amazon REST API. So to make our life easy, our query editor already have a very intuitive GUI tool which help us to load the data. You click on this load data, and from here you can see what's the data source. And but this is for S3 only. Like if your data is coming from, let's say, DynamoDB or other places, then this load then we have to like write actual query. But in this demo we'll see this one only. So we loading from our Amazon S3, we click on this browse, we go into our bucket. So I already have a bucket, and if you're not familiar with S3, I'm going to provide a link for my various videos related to S3, so you will know what exactly is S3 and how we're using it. So click on this, we can pick whatever file we want. So for example, we pick category pipe, it's a text file and it's a delimited file. And these are like small files. I'm going to upload all these, and I got it from the Amazon site only. Okay, choose. Okay, so now we have choose from S3, we provided the path. What kind of file is this? So we'll do this is a delimited file. What kind of delimiter is this? It's a pipe. Let me put the pipe here. And if you want, like we can pick various kind of compression, but I'm not going to do it because I guess this table have only 11 or 10 records. It says ignore the header rows. No, we don't need it. Let me show you the file so it will be easy for you to understand what file is we trying to upload. Let's go to AWS. So if I click on this, so you can see it's a very small file. It have only 11 records and delimited. So this is just for the example. Okay, and the same file I have uploaded into Amazon S3. From there I'm just loading here. Okay, so nothing we have to do so far is just we browse it and we click. Now we click next, like browse the file format. We didn't click on compression, select the delimiter, then click on next. And now when we are loading using this approach, there are like two ways we can do it. Like we can create a we can load this data to an existing table, or we can create into a new table. So when it is an existing table, so there are two ways, like either we have already a table exists there and it has some data, then it will append, or if we can create an empty table and load into this. But in this case, we'll create a new table. So we'll click on this new table. Okay, now we'll do one more thing here. Like for example, you can see your cluster or workgroup basically. So we are picking the marbles because the default cluster and cluster one, they don't have the proper role here. So that's why I'm clicking marble. Div is our database name, schema name is public, and create a table name, let's say test2. Then we choose a role. I'm going to show you how to create this role from where you can read Redshift. Like from Redshift, you can read S3 data. And after that, like here is the mapping. If you want to give name, we can give name. For example, let's say it's ID. What is this data is? Okay, ID type. Okay, ID type. I'm just saying category. And description. Okay, if you want to define any primary key and all those things, options are available here too, but we are not. And we click on table details. This is an interesting part here. Like distribution key and distribution style is auto, so we letting the Redshift to pick it, and same for the sort key, we letting the Redshift to pick it. We are not picking it, and I say like it's a small data. If we want, we can do this. Like for example, distribution key, I personally like we don't need a distribution key. We basically make it all style is and all. We don't need a distribution key here. And for short also, we don't need anything. We just keep it and just click on create table, and this will write a query for you, and then we can run it. It will take some time. In the meantime, 1 second, my system is freeze. It should not take long because like the table is really small, but in the meantime we can go back, open another query editor. Sorry, my bad. Okay, I'm just checking. Oh, so here the table is created. Let's cancel let's close this. Table is created. Load the data. Sorry, my bad. Okay, we're getting some kind of error, but let's go there. So if we go in this one, or the reason being is the cluster, right cluster is not selected. So you see we have marbles dev. Before doing this, I'll show you something, that our table is created but load fails because we need to check if it failed or not. Let's do something here. We go here, do test2, like very simple. Select start from test2 air. From the drop down we select marbles dev is already. We run it. If it is empty, we will get no records. Okay, so after that, like we'll use the query is, you see here the copy command is already here. So it says copy from your database name dev schema public test2 yours and your your S3 path, then what's role you using, formatted delimiter, and reason is this. It got failed because like by default it was the Redshift cluster 2 was selected. Now we run this, and it is loaded with warning. For now, like just ignore the warning, go here, and if we run this again, you will see all the data here. And after this, like you can use this pretty much as any traditional data warehouse you use. The other thing is like IAM role, which I was like I used by default. I created like not the default one, I created it. Let me show you how you, if you want to read the data from Redshift, like from S3 to Redshift, like how can you create a role. Let's go to IAM. And this is just for demo purposes, like depending on your requirement things can change, but I'll show you how to do that. So go in your IAM, click on roles, and roles are basically like when you want to use one service again, like when you want to use services with each other, so you want to give them proper permissions so they can perform the various actions on each other. So click on create role. So this is for AWS service. So this is for Redshift on Amazon S3. So we select Redshift here. Okay. And here there are three options: Redshift customizable, Redshift, and scheduler. So customizable basically allow Redshift clusters to call AWS service on your behalf, and this is pretty much same too, but I'll go customizable where we can see other things. Click on next. And you can see there are various policies which we can attach with this role, and I'll do power user, which provide full access for AWS services. So just click on this, then click like create policy. Sorry, my bad. Next, you don't have to create policy, we are using existing policy. Then we give it a name, so give it like some intuitive name. So for example, Redshift to S3 2. I'm just like S3, something like that. Scroll down, click create role, because I think I already have the same role, but let me do this create role. So because like it already there's already exists, so I'll do something Redshift S3. I'll remove 2 from here. Create role. So it's creating this role, and after that, like you will be like, okay, while creating our cluster or namespace, we didn't mention about this role, or we did the default role. So for that you can modify it, like go there. For example, I'll show you. Let's go to default. For example, this is serverless. Click on security and encryption, just manage role, and here you can type your role. For example, what was our I think Redshift S3. My bad, this is much better. It was not it. So you see, I select this role. No, my bad again. Select this box, associate this role, save changes, and now the role is assigned to this. So once you created like a namespace or a cluster, you still can add the role to it. So now we know, like once our data warehouse is set up, we can perform pretty much all the activities that we can do in traditionally data warehouse in this query editor, for example. Sorry, where is the query? In the query editor, or we can like basically start a SQL client, and from there also we can run all these things. We just need to provide the endpoints, which you can get it from here. Like for example, if we go in a namespace, we go here, click on namespace, marvels, for example, and you will find all these information related to their endpoints and all those kind of information you can get, and from there you can connect. Okay, so that's all for this video. Stay tuned for upcoming video. Thank you. Have a good one.